Hello, welcome to the video. Today we're going to be looking at starting a build on a 60clone, and I know there's a lot of videos about how to make one and showing people assembling them, but this time let's talk about a little bit about soldering first. So here I've got my pile of shit, shit everywhere, and what I'm going to do today is just give a little bit of an overview before I start soldering it up about how I generally solder, because a lot of people show you assembling something but not how to solder. If you're into Commodores or Ataris or whatever, and you thought, I'd like to have a go at that, and you haven't been soldering for years, and you're just wondering how to get into it. So okay, so first of all you're going to need a multimeter. It doesn't need to be a top of the line one. This one is actually not bad. They're relatively cheap. This one, I think this one will come to about 50 quid. If you're over 40, you're definitely going to need a pair of magnifiers. Don't need to say any more than that. This is very, very handy. This is a resistor former. Now, most of the time when you have motherboards that you're going to solder through whole components, the spacing for the components is usually, I do mean only usually, the same right across the board. So having one of these is brilliant. You just drop your component in and bend the legs down, and it fits through perfectly every time. If you don't, and you do it by hand, or a pair of tweezers, or a pair of needle nose pliers or whatever, it's a real pain in the fucking arse. Have a go at that and you'll soon see what I mean. Extractor, definitely a good thing. That's got an activated charcoal filter on it. I'm not going to say that it's the best extractor, but it's better than not having any. And you do want one, because after 6 hours of soldering, you're going to feel like your lungs have fell out your ass. Right, for soldering, I've got a very inexpensive KS Jur. I think you can see that in the back there. Just zoom in. There we go. Now this was off AliExpress and I paid 35 quid for it. And these things are brilliant. It's got a silicone cable, replaceable nibs. The one I've got in there at the minute is my personal favourite, and you can get loads of different types, because over here they're all T12. So you can see here that that's a knife tip, and they just plug in. I don't know if you can see that. Yeah. So you take the end off, obviously when it's cold, and drop in a new tip. But you can get lots of different ones. This is a very fine tip. This one is another tip that I quite like the look of. It's a D one, no, it's a BC2. But you can get lots of different ones to suit your style, and whatever style you have for soldering is something that you pick up as you go along, especially if you're new to it. Tip cleaner. Side cutters are absolutely essential. You're not going to get away with not having them. But if you do get a pair like this that are very thin, don't do what I did and try and cut a bloody pin header with it, because otherwise the end bends up. I don't know if you can see that. Yeah, absolutely beasted that fucking pair. Use something like these. So that's basically the equipment I'm going to use. If I needed to do some surface mount, or I want to do something a bit finer, I have a smaller iron. This is a TS, and these are very good. These have also got replaceable tips, and so there's nothing too complicated. For solder, I'm going to use I always use two types, 0.7 and 0.4 mil. I don't think there's any need for any different sizes. For through hole, you can pretty much get away with 0.7 all the time. If you get into a surface mount, then you're definitely going to want 0.4. Otherwise you are absolutely pissing in the wind trying to solder at 0.7, unless you're flow soldering. So yeah, let's yeah, that was a very quick overview. Let's have a look at the board. Let's put this down. Okay, move some of this out of the way. Nothing like getting a new PCB out. Look at that. Damn. I mean, that just looks absolutely spectacular. Now you can see a lamp. I've got a lamp above me here, and I need that just to be able to see properly. But I do recommend an overhead lamp of some sort. This PCB is finished in a nice nice gold, copper and blue. And if you're going to make a 60 clone, which is what this is, this one has probably got the least amount of components on it to solder. So yeah, that's definitely the way to go. This has come pre-beveled. I don't know if you can see that on there, which was a really nice touch. And yeah, look at that, lovely colour. Not that anyone really gives a fuck when it's inside a case, but that's a story for a different time. So what we're going to do is, a lot of people say start with the smallest components first and build up. I, however, don't. I tend to start with sockets. So there's no right or wrong way. It is what it is. I've managed to get all the components in pretty much. So yeah, let's flip this over. I don't know if we can see properly there. Yeah, looks alright. So the first thing we're going to do is prep ready for soldering. There's no point standing on ceremony, we'll just fucking dive straight into this bastard. So I've actually had this board for about a month, and yeah, so one of the things that can happen is, it probably hasn't happened yet, but we'll clean it just in case, is before you start soldering you want to make sure that it's in a solderable state. So we're going to just give it a little bit of IPA. This is one of those silly Sainsbury's bottles, you know, a 50ml spray bottle. You can buy IPA and just give it a once over. Because if you've got any, if you've got anything on the board that you don't like soldering to, it'll bubble up, and yeah, you'll end up burning the arsehole out of a pin trying to get it to flow properly. So yeah, so we'll just give it a quick once over like that. As you can see, nothing on it, a little bit of blue. Bit surprising that is. Didn't expect that to happen. Still, there we go. Right. Now I tend to use a cheap Chinese flux pen. Do like a bit of flux. You can get lots of different types of flux, and you can have an entire video about flux. In fact, one guy did, and that was a really good video. I'll see if I can find a link to that and put it in the description. And not all fluxes are equal. Some will absolutely corrode the board. So yeah, clean the board after you've soldered it. I don't know how many people just solder something and leave it and it looks absolutely fucking hideous. But yeah, IPA is the stuff. You don't need a lot, especially after soldering. You just need to remove the excess flux and the flux byproduct. Now the other thing to do, that I generally do, is use gloves. More specifically, one glove. So I always tend to handle the solder with one hand, and I solder with the iron with my writing hand. So yeah, I tend to just use a latex glove just to feed the solder. So the next essential item are chinky pots. So next time you have a takeaway, don't throw them away, because you want to get all your stuff ready and separated, so you don't spend half your soldering time looking for the bastard bits. So in here I've got all of the sockets I need, and what I'm going to do is I'm going to pick one to start with, and we'll start with a larger one here. It says if you can separate them. Fuck me, it's cold today. Right, so these are just cheap. I don't know if you can see that well. Let's reposition this a bit. Knock everything over. Lovely. These are cheap double wipe sockets, so nothing special. Just reposition the light closer. Yeah. So if we're going to solder this one in first, we take our flux pen and just draw on there. Draw on there. Lovely bit of flux. We take our component, draw down the outside, draw on the inside, and then we're going to fit this to the board. Now you're going to see that there's an indentation on one end. I don't know if that's coming through okay, and there's an indentation on the board on one end. So all we're going to do is line it up, drop it through like that, and then turn the board back over. Now for the first one, what we need to do is make sure that we're not soldering it out of position and it is flush to the board, and that's the hardest bit, being flush to the board, because if not, you put some pressure onto the socket and these small white contacts can actually come free. So you need it flush to the board. So the first thing I'd do, we're going for 350 degrees. I generally solder at that unless it's a heavy flow item, and I jump it up to 400. So let's have a look here. Let's move this back so hopefully it's on camera. Where are we? Yes, here we go. Now you just touch your soldering iron on the pin and then feed your solder to it so it flows around it. You are not loading up the soldering iron and then applying it to the pin. It's really important. This might be a bit noisy, so I'm going to turn this on now. So there we go, those two pins are on. Now we flip the board over and we make sure that it is flush to the board. You can't see because I've bloody covered up the light, and there we go. And looking at it, that is absolutely hunky-dory. And you might notice that I've put two pins in the middle. That's all I've soldered. That way, if you need to do it, you can give it a little bit of pressure and just reheat your soldered pin, and it will then move flush without dislodging the internal pins. So here we go. Hit the camera. I don't know how people like Gadget UK do this all the time. What a fucking pain in the arse trying to film yourself soldering. Right, here we go. Now once you start and you get a bit of rhythm, you'll know how quickly you can apply the solder and how quickly you can move along. If you leave a small amount of solder on the iron, you've got some thermal mass, so you can actually move quite quickly. So there we go. And The thing is, the hotter you have the iron, the quicker it will take to burn something, but also the quicker you can move. So there's no right or wrong way, it's all about what style you have soldering in. There we go. And because I've pre-fluxed the pins and the board, this is flowing really well. Now, if you're in any doubt that a pin's not gone right, then just reheat it, just reflow it. Don't add any more solder, just see it melt, then drag your soldering iron away from it quickly. Last one was a bit strange. There you go, solid. Okay, and literally the entire VIC-2 chip or socket is soldered, just like that. So once you've got the board's a little bit bent, once you've got a couple in place, you can then use it to lean on with the sockets, so you're not going to do any damage to it. So let's just separate these sockets, which for some reason don't want to separate. What have I done? Oh, come on, come on. Oh, that's been up. There we go. Right. So which one next? So we'll go over the other side of the board now. We'll do a CIA. We'll just draw on these pins. These flux pens are really good. You can pick them up for literally like £1.50 from Slow Boat from China. So if you're going to do something like this, give yourself a bit of planning and don't leave it to the last minute to buy anything, because that's really going to piss you off if you're sitting there waiting for 6 weeks for something to arrive. But it is cheap. So let's drop that in there. So again, I've located the notch at the top where it's on the silk screen. I'm going to apply some pressure to that if I haven't just dropped it. There we go, let's try that again. There. So just pop up the back of that board there for a second. No, it's too high. Right, I'll just give it some pressure. Okay, here we go. Does that look? Absolutely superb. Right, that's flush. So all I'm going to do is I'm going to lean on it as I'm soldering, just to make sure that it is correct. And I'm going to move it back so hopefully we can see. Okay. Once you're applying the solder, you'll see it capillary action straight into the hole, and then suddenly the hole will fill up and you'll have a nice joint. I realise my hand's blocking the camera. Nice. I mean, you can solder a lot cooler than I've got the iron, and a lot of people do, and you can also go hotter, but it will take longer, especially to flow if you go any cooler. You can see the amount of smoke coming off. That's where it's heating up the flux. It's not really something you want to be breathing in, hence the reason for the extraction or the fan. I don't know how long this is actually going to take to assemble completely, but I did a C128 Neo, and that took 12 hours in total, but a good portion of that was looking for some bits, because I wasn't organised, so yeah. There we go. Superb. There's lots of residue left on the board, and that's from the flux and the flux in the solder I'm using. I'm using the Wharton Metals solder. It's quite nice. It's not dear, it's not cheap either. I would absolutely avoid getting any kind of cheap ass fucking no name bollocks solder like this, because this is absolutely fucking diabolical. I don't even know what's in it, what type of metal. It's some strange shit. So there we go. 2 sockets on. Now we're getting somewhere. Okay, so for the next bit, I'm going to speed up the video and just crack on. Okay, so it's so cold out here that the camera keeps bloody turning off. So in just about an hour's worth of soldering, I've soldered all of the sockets completely onto the board. So that's really not bad. As you can see, that's a big portion of it done. I suspect that we could do the entire board in maybe 3 hours. So yeah, that's not too bad at all. Yeah, at the moment I'm going to get out the cold, and we'll pick this up with the passives next time. Okay, so this is the next day, and it's still bastard fucking cold. So yeah, when I ordered this board off Tindy, I also ordered the resistors and the resistor networks to come with it. So we'll go and try and get a few of those on today. Let's power up the soldering iron. Fucking hell, it's cold. So okay, so what we're going to do today, first of all, is work out which resistors are which, drop them in place and stitch them in. Now the good thing about this board, as you can see here, is all the silk screen is labelled. I mean, this is fantastic. It's got values on and everything. You really can't fuck this up. So let's start with resistor networks. Soldering irons up to temperature. So on here, I don't know if we can get that on the camera properly. So for the 466 pack, it's already done for you. These are resistor networks. Now I don't know if you know about resistor networks, but they're basically exactly the same as a load of hand two wire resistors, but it's like twisting one of the wires together. So if you've got a network that's got 5 resistors in it, like this one, you can see that the 6th pin is got a dot next to it. I don't know if you can see this well enough on the camera, but yeah, that dot is the common. So if you imagine you've got 5 resistors and you've twisted one end all together, this would be the common. Now there are other types of busing they do. They could be in, if you had a 9 pin, it could be, or 10 pin, it could be 2 lots of 4 resistors. But that's the basic sort of premise behind it. Right, let's get a glove on ready. You don't, you know, it probably won't hurt you, but I've always handled solder with a glove on, especially for long periods of time. And always wash your hands afterwards. That goes without saying. Right. So, resistor packs. On the silk screen, you'll see that one of the holes has got a square around it. So let's see if I can get that on camera there. So this end hole has got a square around it. So that would be the one where your dot on the resistor pack goes. So let's have a look. And they're all different values. That's absolutely unhelpful. So it's a 330, 330, 332, 102 and 332. Okay. Oh. So we've got 233 ohms. So that'll be these two. The rest of them, you've got one of each. So that's happy days. Right, so the first thing we've got to do is find the 33 ohm bust ones. That's one, so that's these two here. But look at this. Yep, 33R, 33R, yep. And this one's got a line signifying, I don't know if you can see that on camera very well, a line signifying the common. So we'll just drop that in there like so. We'll do that to both of those. And they tend to fall one way or the other in the slot or in the pins. So flip it over. Now because I've already put the sockets in place, the resistor networks, they're not going to move too far. So just like I did before, I know I'm covering up what I'm soldering now. Let's get some glasses on so I can see what I'm doing. One single pin. I'm not worrying about flux because it's not really going to matter on this too much. And you can see they're both tilted over and sticking out. So because I've only soldered one pin, I put my fingers underneath, you can see this, and then I heat the pin, and then I realign it to how I want it. Same as on the other one. You hold it with your fingertips, heat the pin, realign it, like so. That also flushes it up to the board. So let's get this soldered in. I'm going to try and solder it so you can see me doing it. Right, here we go. Again, heat the pin, then apply a solder to the pin itself, not to the iron. As soon as you do this a few times, you'll soon get the hang of it. It's not rocket science. Although, I am going to have some extraction. Okay, here we go. If you're not using flux, it might take a slight amount of time longer just to make sure you've got enough heat there for it to flow. Now when we turn this back over, you'll see that they're both in alignment, and yeah, nice. So now we've just got to find the other networks. What we've got here, we've got 332, that's an 8 pin. Can only go there. And we've got one that can only go there. Lovely. Of course it is. Let's get that the right way round. It's often quite difficult to hold them in position when you're flipping the board over as well. But you've only got to tack them in place, and then your fingertips can do the rest. There we go. And you can feel it as you go to move them. Don't you be tempted just to bend it. Don't until you heat up the pin. There you go, just like that. Nice. There we go. And then we'll just flow that solder on. And it needs a drop more on that one, so we'll just go back and do that. There we go. Now when I solder a joint, you'll see me whip the iron away quite quickly. That's how you leave a good joint behind. That's how I do anyway. Lovely. Got one more resistor pack left. It's over here by the cartridge port. So let's drop that one on. And so he drops it right off the board. Nice. Yeah, you've got to make sure you orientate it the right way, otherwise you're going to get some funky troubleshooting issues later, if it works at all. There you go. Now, like I said yesterday, I use 350 degrees. Your mileage may vary. That's good for me. I've found that if you go lower, you can end up burning it more because you have to hold it on longer to get the heat transfer. I was asked about it as that sounds. Okay, so here we are. And right, so all the resistor networks are in place. There was only 5. Excellent. Right, here we've got a bunch of metal film resistors. And what we've got to do is we've got to get these onto the board in the right places. To state the bloody obvious. Now the issue here is, unless you know your resistors by band, you're going to have to measure them. Then you've got to find out where they are on the board. So we take our trusty multimeter, and then you just got to, let's have a look, ohms, yada yada yada. Right, let's move this out of the way a second. I don't know if you can, no, you can't see this because the light's in the way. Can you see that? No, because the light is still in the way. Super reflection. There we go. Right, so right now it says open loop. Let's have a look. So we've got it set to ohms, and we just drop that across the 2 probes, and then boom. Now it's 9.894k, right? So because there's a tolerance on metal film, it's usually 1%, can be 5 if they're really shit ones, but yeah, that's obviously a 10k resistor. So the next problem we got is finding it. So you're looking over the board now. R7's 10k. How many does it say we have? 1k, 1.523, 1 times 10k R7. There you go. So what you do is you take your former, this, and you offer it up to the board. Now this one looks like 0.5 inch is the one to go, or in new money that's 12mm. You can do it on either side, it doesn't really matter. So the sides on this are for the bigger and smaller devices, so if we know it's 0.5, what I'm going to do is I'm not even going to mark it. I'm just going to bend them down like that, and then whop. The leads are automatically bent to the right spacing. So pull off the little bits of paper on the end, drop that through R7, and this is the bit that's really going to start taking the time up. On the back of the board I tend to cross them. That's just my own thing, just to keep them in position like that. I don't know if we can see here, yeah, because I'll go back and I'll start soldering all up in one hit. So next one, we've got a lot of single resistors here. So it's 550R, and we've got 560R. So I would have said that's right, and that's R5. Now we've got to find bloody R5. So again, I've just bent them down the sides, taken it off, and I'm ready to fix it in position. If I can actually find where R5 is. Brilliant. And I've got glasses on. R5 there, 560R. So we'll just drop that through, hold it flush on the board, and then cross them over on the back. Next one. Here we go. Right, 466. 466M. So that's 470k. I would have said that is. What we got on here? And we've got one on R35, 470k. So we'll bend that down. Boom. And that says it is R35. We've got to find that fucking R35 470k, nice. Again, do the cross it over. They don't matter if they overlap when they start getting next to each other, because generally you solder one side, pull the other side up and trim it off. Takes a little bit longer, but it's worth it. Right, what we've got here, 387 or 0.387k. So I reckon that is going to be 390R. Yep, and that's R39. We'll go again and boom. R39, where are you at? Cool. R39. Six. Oh, right down in the corner over here. Yeah, lovely jubbly. Just pop that over there like that. Sorted. Next one. I'm doing the single ones first, because once they're all the same colour and they're on a strip, you're just gonna drop them all in. You're only gonna measure once. Right, what we've got here, that is obviously 100R. There we go, boom. So 100R, where are you at? R100 is R60. So R60, where are you? R60. R37. There we go, right up the top there, and they just fit straight in. Now you've pre-formed the legs. Right, next, $1.5k, R51, lovely, R51. There. Right, so rather than keep narrating this now, what I'm going to do is I'm just going to crack on and speed this up. Right, so here we are back again. The camera seems to have shut itself down yet again. I can't hear it close because the fan's on. So I've got all of the resistors in position now. It's just time to stitch them on. So I'll flip over the board, and it looks a bit of a mess, but reality is all you've got to do is just stitch down one side and then trim the other side and just stitch that down. It's really quite simple. So yeah, let's get into it. Now as you're doing it, you may need to move one of your legs out of the way or whatever, but I tend to just fix in place one side of each component because you can still move it easily then. Again, you don't really need the flux for this because you're not really going at light speed like with the sockets. You can use flux, it won't hurt nothing, but as long as you flow it properly, you've got no problem just soldering direct. Again, leave a little bit of solder on your iron, just enough to get the thermal mass to start flowing okay. Go. This part shouldn't take too long at all. There's not so many components on this board. It really is a nice board to solder. It's like the 1581 replicas. They're quite nice as well. You can build one of them in about 3 hours start to finish. Nice. You may have noticed that when I bend the legs down, I bend them across so they're not parallel to each other, because that way you can still get in afterwards. Okay, that one didn't want to flow very well. Down there. Might be because it's just so fucking cold. Okay, so I think we're pretty good. We've got one side of all the resistors down there. So then all we do is then just lift up the other sides. Not enough to push them through, but just lift them up, ready. Right, so here we are. This is the third time I've sat down at this. It's still bastard cold. Yeah, so where do we get to? We've got all the sockets on, all the resistor packs and resistors on. So now we've got a bit of a time consuming bit where we've got to put the odds and sods on. Now there's a few of these and they all look similar, so we'll start with the capacitors. Now a lot of the capacitors are not polarized, so you can put them on either way round. It's up to you. The ones that are polarized will generally have a little plus on the board. Electrolytics definitely are polarized, as you can see here. But for regular ceramic types, yeah, you can just drop them in either way round. That's up to you. I've got some of the components from Mouser, and as you can see here, they come with a nice little description of what they are on the front, so you don't have to worry about belling them out. You can just, you know, crack on. It still takes a little bit of time, as you've got to locate each one, and as I've just found from Mouser, one of them is not even labelled, so that one's going to be fun. Yeah, so the first thing we're going to do here is we're going to start with the 470 PF, which is picofarad or puff. The 470 PFs or 470 puffs will have a small, well, they'll all have a small indicator written on them. So 470 should have 471 written on it. I'm not sure I'll be able to pick this up on the camera. Let's have a look. Here we go. And yeah, these ones are a nice blue. I don't think you'll be able to see that, but yeah, it's got 471 on it. And you can see the lead spacings here are 5mm, and they've got a nice little shoulder on it. The problem is in soldering them in. It's not very nice to do. They tend to wobble in the hole like that. So getting them nice is it takes a little bit extra work. So let's have a look. See, look on the bomb. It says 470 puff. See 10, 11. 150 to 152 and 154. So what you've got to do is, these are on tape, and that's an absolute shit. So what I'm going to do here is just try and make it easier to get it out the tape. Score down either side. If you just try and tear it out, I'll tell you what will happen. You'll bend the legs all over the place. So what I'm going to do is just scribe down it with a blade on the inside. Here's where I end up bending all the legs anyway. Nice. I'm going to do this to all of them. I haven't got many in this pack, so it doesn't really matter. Whenever I order from Mouser, I always chuck a couple of extras on, unless they're stupid prices. You know, if you're only paying sort of 5p for a component, chuck a couple more on. Don't give yourself any grief. So there we go. So that one came out relatively okay, as you can see. We're going to look there, and we can see the writings on one side, and we're going to look for C10 first of all. Fancy 11. Okay. Arguably this takes the most amount of time when you're putting components on, just finding out where the fuck they've got to go. C10. Where's that? C59. There it is. So yeah, just drop it through there and you can see how it's going to sit, and it doesn't even sit well when you drop it through. It tends to sort of lean over. There's no nice way of doing this. So we've got to put in C10 and C11. So I'm going to hold the board up like that. We'll take the next one out of the tape I've scored, and that one didn't work so well. Okay, and I'm going to drop that in like that. Now what I tend to do, and this is all down to preference, is I tend to leave the writing facing the direction where you can actually see it. So I know it sounds a bit common sensey, but here I've left the writing facing one way so I can actually get to it. When you've got them on the end of chips like you do decoupling caps, don't face it the chip, face it outwards so you can actually see it. Although decoupling is normally, I do mean all things being equal, 0.1 microfarads anyway, or 100 nanos. Right, so I've just put these two in here, and as you can see that they're flopping around all over the place. So just try and get them sort of in a position where you're half happy with it, and then what we're going to do is just put a drop of solder on each one, just on one leg. Now I grab the other leg, it's going to be difficult for you to see me do it, I grab the other leg and pull upwards on it while I apply heat to the first leg and just melt it into a new position. So what I'm doing is I'm pulling it up to the board. But I'm obviously not holding the leg I'm about to reheat again. Now, so I've just done that, and as I've lifted it up, I've applied solder to the opposite leg, the one I've just soldered, and hopefully I should be in the right place. Yeah, I'm happy with that. So then you go back and then you stitch the other leg in. Now it's worth noting that if you do take this approach, just go back and reflow the first leg after the second leg's cooled. The reason for that is you've just dragged metal through it, so you know you've got a little bit of a chance of a dry joint appearing. And that's it, that's two in. So let's cut them off. Nice. Right, so that's 10 and 11. Then we've got 150, 151 and 152. Now these three are there in a row, no problem. Just spotted those. I was doing the last ones. Okay, come on, add your come. This tape really is shit sometimes, but it's not made for people to do it. I think it's made to be peeled off in a machine. Yeah, so there we go. Let's just try and free up a leg. More often than not you end up bloody bending it anyway. So if you just bend it outwards across your cut you've made, sometimes you can just free it. Other times it leaves it on there. Let's see, I've bent them legs, but that's not going to matter too much. Trust me, it's a lot easier than not scoring it and trying to tear them out. End up beasting the arsehole out of it. Okay, so here we go. Now these are actually nicely labelled on the silk screen as 471s, so you can't get that wrong. And if you look behind it, there's going to be a decoupling cap. So I'm going to face the writing so that you could read it if you're looking in from the back. So I'm just going to drop these three in here. Not that I can see it without a pair of magnifiers on anyway. There we go. Same deal, all three are in. I'm just going to flip it over, put them down on the floor like that, and then I'm just going to tack in one leg on each. Now if you've done all your sockets first, and I know that's the polar opposite to how some people do it, but it means that you're going to be in the ballpark, because your sockets, they can't really drop any lower than your sockets, because that's what your board's going to rest on. So it's just a matter of positioning. So grab the opposite leg, heat it, boom, pull it up. Nice. And again, come on. That one's alright. Come on, you fucker. Guess they're alright. Let's have a look. And yeah, they're all okay. Excellent. We'll stitch them fuckers in now. I don't know why the holes are so big on this board. It really drops some solder into them. Let's go back and reflow the first hole. Come on. Nice. Now with all the faffing around and trying to find the components, dropping them on and everything else, this bit does take some time. You're not going to get around that. Just accept it and go with it. Right, so we've got one more, and that's on 154. As you can see, I've got a few spares on this one. God, get out, you bastard. Right, C154, where the fuck have you gone? There it is, nice. So you can read it from both sides, so it's just preference which way round. I'm going to face it towards the cassette port. There we go. And it's, yeah, come on, get in. Now, I'm just going to pull upwards and nice. And as you can see, that's absolutely gone in on the piss. So that one has not gone right at all. Just got to go through there. How the hell am I going to straighten that out? Okay. Try and heat it up from this side of the board. No, not a chance. Let's try pulling it up. That's gone a bit wonky, that one. Right, I need to pull this up on the leg that I've soldered, unfortunately, so I'm just going to get a pair of pliers. I'm going to put my soldering iron in booster mode, which takes up to 400. I'm going to grab hold of this. Okay, let's try another marginally less shit pair. Come on, and up you come. Let's try that. That's got it. That looks a lot better. Let's just drop that in. So even at 400 you can solder no problem. Just be aware that you've got less time to do shit before it'll burn. So if you're new to soldering, definitely chill that fucker out a bit. Right, so that is all of the 470 perfs in position. Put the remainder in here. Got a nice little box full of all the unused components from when I did the other drive, the other board, which was the 15, the C128 Neo. Okay, so here we go. 100 volts, 68 puffs, and it's an MLCC, which is just another fancy way of saying it's a ceramic capacitor. It's a multi-layer ceramic capacitor to be exact. Okay, was that 68 puffs? Yeah, 68 puffs. We only got one of these, and that's C153. Okay, now this is an axial, so they tend to gonna come flat like that, so we're gonna need to bend that. C153. Well, this should be here we go again. There it is, and that's quite a small one there. So what I'm going to tend to do then is I'm going to just gently bend the legs quite close to the bead. I'm going to bend it straight down like that. You've only got one of these, so if you do use a pair of pliers to do this, just be aware that as you bend it, you've got the thickness of the pliers that may contact the bead, so don't go right up to it and try and bend it, because all you do is you'll crack the ceramic. So let's drop that into C153. Look at that, straight in, and that'll sit flush to the board. So same deal as before. There we go, grab the other leg, pull it up flush. It moved about 5 mil that time, so you can see that the solder side needs to come up a bit more now. So same deal as before. Going to grab hold of the top of the solder leg with the pliers. Just apply a little bit of heat just to melt it, and just pull it upwards. Nice. Lovely. That'll do. And then we shall just heat that up and trim it off flush. Right, so 68 puffs done. That's the it's the only one on the board, so that's okay. Next one, we've got 1.2 micro Henry. Now that's an inductor. Inductor, for the purposes of what we're going to do, is like a resistor. And the inductor is non-polarized. You can put it around either way. It'll just need forming. So let's have a look on there. Ceramics, connectors, MISC. Here we go. Inductors have the prefix L usually, whereas you'd have C for capacitor, R for resistance or resistor, L would be an inductor. So what we've got here is a 1.2 UH, which is micro Henry, and that's going in at L5. Lovely. You can see I've bought 2. So we're just going to take one of those out, and we are going to need to form this, so let's see where that goes on the board. There it is, L5. It's usually near power. An inductor resists change over time. It stores energy as a magnetic field, and then it resists the change to it. They can do a lot of different things. There we go. I don't know, it could be 5.5, that one. Yeah, 0.55. So let's just bend them legs down. Lovely. Those formers are superb. You can get them off eBay, or if you've got a 3D printer you can do it just as easily. And then we'll drop, look at that, spot on. There we go, and I'm just going to pull that one up. Come on, there you go. Oh, it needs to come up again, but this time I can push from the other side. There's nothing near it, so no, don't push from the other side, you can't get it high enough. Let's get in there with these again. Come on. There you go. Probably heard it go. Did I go too far? Yes I did, I nearly pulled it right through the fucking board. Right, come on, straighten out. There we go. Let's try that one. Perfect. See, that one took 3 attempts, and you know, unfortunately shit happens. So cold, I haven't put the bloody... That's better. Trust me, you go in for a few hours of soldering, and you don't have an extractor on the next day, your lungs feel like they've been through a cheese grater. So that looks good. There we go. Right, that's the 1.2 microhenry inductor done. What have we got next here? Okay, so we've got 6.8 volt Zener diode. Now a Zener, well, a diode lets electricity go one way. A Zener lets it go one way, but it'll also go the other way once it reaches its rated value. So it'll let electricity go one way in its normal configuration, but as soon as it hits 6.8 volts in the reverse direction, it'll let it flow that way too. Some people call them windmill diodes. There we go. And these have got the designation D. Fortunately, the camera keeps turning itself off because it's so cold. You'll notice that with a diode, one end will be black. Or if it's a rectifier diode, it'll be a black body with a silver end. Now that black end has got to go to the top of the triangle. So we're looking at CR2. Let's just double check that. 6.8 volts Zener. So as you can see here, CR2's there. And we want the black line to be this side. So what we're going to do is hit the camera, and we're going to just drop that through the board like that, just like that. So that's how we're going to fix that. It's the same with all diodes. Mind you, a lot of people, if you're going to be doing this sort of thing, you've probably already got a pretty good idea of what's what with a diode and capacitor and everything else. But that's no reason to say that anyone can't have a go. It's really easy. Right, so when I built the C128 Neo, I had a bunch of these nice blue 0.1 farad decoupling caps left over, so I thought I'd reuse them for this project. Yeah, so I've just put 3 on the board. This is how many we've got to do in total, and I've just soldered them on. These are going to be the biggest amount, so I'm just going to crack on. Right, yeah, so as I was saying, decoupling caps are on. Everything, all the passives are nearly on. There's only a few holes left. Yeah, so after that it's cracking on with the connectors and other stuff. So 3 hours, it's not bad at all. Not bad at all. Yeah, so the decoupling caps, for those that you don't know, they stick one near each chip, and the reason for it is, in a digital system, all the chips pull power at different times, so they act like little reservoirs of power, so it doesn't send the power supply crazy, you know, and that's the reason for it. 0.1 microfarads is fairly standard for 5-volt TTL logic and computers and stuff like that. Yeah, that's 100 nanofarads, and you'll see it with 104 written on it. You can't miss them. You can see them in all digital stuff pretty much. So yeah, 3 hours to here. Next time we'll start whacking on the other components. Right, here we are back on the bench. It's bloody cold again, still in this cold snap. So where have we got to? Yep, we've got a lot of the passives on. I seem to be missing a couple of pieces, but hopefully that will become apparent soon. So now we get to put some of the fun stuff on. Nothing now is really going to sit too close to the board, so yeah, let's just crack on. Because I've got a Commodore to go on here, I don't need to worry about populating the clock chip, the crystal or the jumper yet. So I'm just going to pop on this tiny little variable capacitor. So as we can see, it's a 5 to 40 pico. So I'm just going to drop that through the board, flip out and stitch that in. There's my glasses. There we go. That didn't go down very well. I should have fluxed that. Come on. Reflow that one. Doesn't like something or other. Nice. Sorted. Hopefully I haven't just melted the arsehole out of it. That looks alright. Good. So that's ready there. Let's go with some electrolytics. This is a pack I got from Retro ReFix, where I get a lot of stuff. So a lot of this stuff is so easy to work out where it goes. It's all marked clearly. Electrolytics are all polarized, unless you buy special unpolarized versions, but the only time I've seen one of them used on the home computer is an Atari 800, an XE. So as we haven't got one of them, we don't have to worry about that. So each one of these has got a line down one side. As you can see here, it's minus. So, and the board's already marked up. So all we've got to do is find out what we got here. We got a 50 volt 2.2 microfarad right here. Now I tend to lay these down. You can solder them directly sitting up, but just for me, I mean, that's just my preference. I tend to lay them down where possible. So same deal as I've done before. Just going to stitch that one in, grab hold of the leg and then try and pull it flat. Just push to the board. If you do go to lay them down, just be aware that if you try to force them down and you haven't left enough leg, you can pull the leg out of the component. So yeah, don't do that. There we go. Lovely. Trim that off. Now once it's on, just position it where I want it. Lovely. There's a positive and a positive marked on the board and a negative marked on the component, so it's really quite easy to see. Can't get it wrong. Well, you can if you really try, but don't try. Right, what have we got here? 10 UF, 10 micros, 25 volt, it's 22, 100 and 10. So we've got 2 of these 10 UFs. It looks like it's all we've got. So we've got one at 210 and one at C13. So let me just check the bomb. Here we go. C13 210, yep. Okay. So I'll just put them down, make sure I pick the right ones up. Yep. Again, you've got the same deal, positives marked. So the longest leg's positive. Drop it in, bend it over and position it. Nice. There we go. So I'm just going to stitch one leg in. There we go. Have a look. Yeah, it's sitting flush. Nice. Like I said, you don't have to sit them flush to the board. I do that because I like to. If there's space, it just means if you're in there messing around with stuff, you're unlikely to catch it. Start knocking them around. That never ends well. Go. Lovely. Yeah, for this build, I've got quite a lot of stuff from Retro ReFix. I believe his name's Phil Ruston. I may have said this earlier, but I've been building this over. This is the 4th time I've sat down to it over as many days. So got some really good customer service as well. Missed something off one of my orders, emailed him, next thing you know it's on my doorstep. No messing around. There we go, that's those in. What else have we got here? So we got 2 no, it's 22. It's this one down here. Nice. Now when getting capacitors, don't cheap out. It will save you having to replace them later. Now with a capacitor you can go with a higher voltage rating, as long as you don't go too high. So it's within reason. So if you've got a 16 volt, it's fine to put a 25 volt in its place at the same farad amount. And where possible, use 105 degree C capacitors, low ESR. But I mean, these ones are putting in here, they're 85 degrees, they'll be fine. Let's have a look what we've got left. 100 micros at 16 volts. Boom, 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 boom. These have got to be fairly easy to see on the board. There. Go. Lovely. Now one thing to note with electrolytics is you don't want to be burning the arsehole out of them on the board. So Lovely. Don't be holding your soldering iron on there too long, because you certainly don't want it destroying the capacitor. They're not overly sensitive, but they are made out of a fairly low melting point plastic inside. Just don't do it. As I said in the other parts of this video, I use 350 degrees and I can, you know, melt the solder pretty bloody quickly. So there we go, that's those on. Now we've got axials. These are a bit more of a pig item. Right, so you can see the negative running down one side and pointing to the negative leg, which is this one. And that means that's the positive. So trying to bend these is, well, you're going to have to just offer it up and bend it by eye. There you go. And try and position them how you want them. There's no right or wrong way of doing this. Some people use tape. I really can't be asked at the moment, so I'm just gonna feel my way through that and then just stitch it in. Stop leaving my pliers there. Really not a fan of these big holes on this board. Bloody hell, they're monstrous. There we go, looks pretty cool. Nice, like a nice crisp sort of right angle to it as I do it, but that's just aesthetical, doesn't matter a fuck. Right, there we go. We've got next 2200, this one, yeah, again that's that. So yeah, yeah, there we go. Get in there. Same trick as before, heat up one leg, position it, check it's where you want it, and stitch it. God damn, it's cold. Okay, should have put this next one on first, I should think. As it's smaller, it's going to drift away from the board, but there you go. Shit happens. Come on. Bend that out slightly, it might hold its position. Okay, let's have a look at how that looks. It's actually not bad. Okay, stitch it in. What I do like, what I've just noticed about this board is you don't have to use axials, you can use radial capacitors, because he had the foresight to put an extra set of terminals down one end. So as you can see there, only the middle one is positive, and I've put the numbers upwards and you can see that okay. Lovely. Right, that is all the electrolytics on. What we got next? Right, next we've got fuse holder. Look at that. Now you need to get that round the right way. It's hard to see, but there's a small indent on one end which polarizes it. Otherwise you'll be able to get it in there, but it will just, that'll look shit. Oh, right, well, yeah, I probably should have put that on before the capacitors. So that's not actually sitting in there very well, so I'm just going to bend these outwards to give it a little bit of purchase. There we go. Hopefully stop it dropping out. So when it's on this side, I'm going to force that out a bit. Don't have to cut them off, so yeah. Bloody camera turned itself off again because it's so bloody cold. Right, so much for fucking global warming. Right, here we go, and that's flush. Right, so this will be the fuse holder in position. Lovely. That's that done. Okay, so that's the fuse holder done. Right, so I'm back again, and this is the fourth time I believe I've sat down at this. Most of it's now complete, as you can see, and yeah, still pretty fucking cold. So what we're going to do is we're going to sort the cartridge port out now. That's a bit of a, I've got my own way of doing that, and I'm going to epoxy it in position before I solder it. And the reason for that is, if you've got a Commodore 64, you're going to be ramming a cartridge in and out of it all the time. Everyone does with a Commodore. If you're going to use it, you're going to use a cartridge of some sort. So what we're going to do is fit the cartridge port and epoxy it in position before we solder it. And that's really important because we don't want to be putting any strain on the pins. So I've got an old piece of plastic here that something turned up in. I'm going to use that to mix up the epoxy. I'm going to use some cheap Chinese two-part epoxy, as we can see here. I've got a pack of 5 of these cartridge ports from Korea. They took a long while to get here. So what we're going to do is scuff that up first. So, yeah. That'll do. Well, a little sliver of sandpaper, and all I'm going to do is just scuff up the mating face. Can't see it at the moment because my hand's in the way, I guess, but there we go. I don't know if you can see that, but it just roughs up the surface a bit. 4 zip ties. These are massively overkill for what I'm about to do, but what we're going to do here is fit them together like this. Here we go. Lovely. So we're going to fit them together like that. And then we're going to shrink this down so that it clamps the cartridge port to the board itself. So get it down to a sort of sensible size before you start, and then you can put that to one side for now. You're not going to have very long at all. Once you mix this shit up, it goes off fast. So here we go. We've got glue and hardener. It's still bastard cold, so it will take a little bit longer than normal to go off. These are unopened, so I'm just going to pierce that and just put a little tiny. Now think about what you're doing here, because you're going to want enough to go right across the bottom of it. And this tube appears to be full of mostly fucking air rather than glue. There we go. God, fuck me, that stinks. Right, hardener. You want a 50-50 mix. So when you're thinking about the amount you're squeezing out, think you're going to end up with double of it. There you go, look at that. And then just mix it together with the handy dandy applicator. Make a nice little mound of it, and then bring your board in like so. Right, the first thing we want to do is spoon that onto the board in a row. There's no nice way of doing this. Just get it roughly in position, because you're going to clamp it down with the zip ties in a moment. So there we go, that's all there is to that. Now we drop this through like so, and then we take our makeshift zip tie clamp and we shrink it down to fit. This is the fun part, because if you go too far too fast, it won't go over the bloody item. That's it. So there we go. Nice. And we'll hold it in position, and then you've got to tighten that fucker up. Don't be too afraid we're going a bit brutal with this, because you've got to get it in position. You haven't got much time to do it. There we go, that's kind of right, but not quite. So what we're going to do, we're going to get a pair of pliers. I don't know if you can see this okay, and this is my own technique. You just take this and you twist it, and you'll hear it go ping ping ping, hopefully not snap. Don't give it too much Ned Ted. You'll hear it just pull another couple of ratchets on it, and that fucker will hold it tight. Yes, lovely. I'll miss that component there hopefully and not fucking break it. Lovely. So now that's held that in position. Just hold it close to my face for a second so I can see if it's actually where I want it. Now manoeuvre, while you've got some play in it, manoeuvre it towards the end of the PCB like that, and as far as it can go, and then that's it, it's tight. Now in this case the PCB is a little bit longer than the cartridge slot, and that's because the cartridge slot was probably not the original. Now we're going to cut these off, because there's no point taking them off until you know it's cured, and we're going to know it's cured in 24 hours. Trust me, it's probably going to be okay in 5 minutes, but there you go. So that's not soldered on, but it's being held in position with 4 bastard strong zip ties. And that's just my way of doing it. I did that with a Neo. Once that goes off, and it will take a bit longer in this weather compared to when it's hot, then you'll see all the pins are there ready to solder. Absolutely no issue at all. Now our handy dandy applicator is now covered in shit, so let's clean that up before it goes off, preferably. There we go. Lovely, look at that. And we can put that away. Ready for the next time we use that shit. This stuff, I mean, I got this from China for £1, so yeah, it's ridiculously cheap. I bought it ages ago. It's got quite a good shelf life and it's quite strong. I don't recommend changing the mixture up anything other than 1:1. That's really what you want. Right, so we've got 1815 transistors to go in position. There's only 4 of these on the board. Now, because a transistor can have its legs in 2 different or 3 different configurations, whatever it is, you've got 3 pins. Yeah, you just got to make sure that you follow the silkscreen mask, which has a flat on one side of it, and that is obviously for the flat of this. So I'm just going to pull up the bomb on the phone. God, so many tabs open. There we go. Commodore bomb list. Here we go. Right, Q2, 3 and 4 a small signal 1815s. So there's only 3 of them. Okay, no problem. These were a doddle now. I bought a pack of 10. They weren't very dear. Mouser was out of stock, so I had to go to eBay. Yeah, you got to be a little bit careful when you go to eBay. You never know what you're going to get. But I'm going to trust these off the bat. Speaking of components, there's a bit of an issue with a couple of the bits here that I'm going to have to rectify in part 2 of this video. So, I mean, this video is going to be long enough as it is. Here we go. Let's just drop that in. Right, what have we got? Q3 and 4. That's it, and I think it's Q2 as well. Yeah, where's Q2? There, right there. No searching for that fucker. Double check they're the right way round. Yes, yes, yes. Flip the board. Okay. Right, let's get a glove on. Right. Look at that. Nearly done. Glasses. Can't see fuck all. There we go. So again, just solder 1 pin, just tack it. I've cut some bloody wire everywhere. Right, I'm going to go with a middle pin just to make it easier to reposition. Really doesn't matter. This is how I solder. I mean, once you get into it, you can have your own way of doing it. No one's right or wrong. It's just what's right for you. Right, yeah, this one's a bit pissed, so we're gonna just use our finger to reposition it. There we go. Bit more. Lovely. This one down here looks okay. Yeah, I don't really push them close to the board. I don't think there's any real need for that. What you've got to do really is just make sure that you can get to them. Let's have a look at that. Yeah, so I've got between 5 and 7 mil to the transistor head from the board. Like I said before, there's no right or wrong way. is what it is. Okay. I still can't get over the size of the bloody through holes on this. There we go. Solder this one down here. It's bloody difficult soldering on camera, I can tell you that much. There we go. Superb. Right, I'm going to trim this off. Yeah. There we go. 3 legs on each. Bing, bing, bing. Job is a good one. Right. So they're all on. No problems there at all. What else do we have to put on? So power switch. Again from Retroleum. Now he does proper clone ones. So I don't know where he gets them from, but they're spot on. So you've got 2 wings at one end. They go through. And the whole thing just sits flush to the board. So no messing around. Just tack it down. And in this case, because I've got something underneath it, I'm going to need to prop that up with something. I'll use that. There we go. So I'm just going to tack one wing in, and that's absorbing a lot of heat. So I'm going to boost this up to 400. This is why you need a boost. There we go. I'm just going to tack that one in, and 1 foot opposite. There we go. Now let's have a look. That is fucking diabolical. So I'm going to heat that up and push it through at the same time. Let's have a look at how it looks. Now I'm going to say that looks absolutely spot on now, so I'm going to stitch that in place. There we go. So just heat up the foot and just feed the solder in. There we go, come on, round you go. Look at that. This is at 400. You've got so much thermal mass, you need the extra energy. There we go. They're in. Let's do the back end. This is the actual terminals. Lovely. So always apply the iron heat and then apply the solder to the component, and it should flow round nicely, and then just pull the iron away just like that. Brilliant. So we've got power switch now. Look at that. What else can we put in position? Well, okay, so we've got an 8-pin connector for the video, 6-pin for the serial. Now these come in different types, and it's the ground anchor point is different widths. So let's just get that down. Now for these it's imperative they're flat to the board. I'll tell you why, because if they're not, you're going to put strain on it. No ifs, no buts, you'll break something. So what I tend to do is I put just one ground pin soldered, and they're the ones closest to where you plug it into. They're like an anchor and that way you can manipulate the rest of it. So you put a little bit of pressure on it, then reheat it. And I felt it move. Good call. This one, that didn't move, so that must have been okay. Right, they both look flush. So now I'm going to do the same, but with a very back pin in the middle. Lovely. Lovely. And again, I'm going to put a little bit of pressure on the board and just reflow it. Didn't move. Oh, click. That moved. Now you've got two of them holding it down. It should be completely flat to the board, and it is. So while that's the case, stitch the rest in. Here at 400 degrees really helps, because you can just flow it so nicely. There's no real order to this other than what you want to do. For me personally, it's like doing up a set of bolts on something. You want an even pressure, you go across it. You don't just all do it on one side then the other. I haven't got the fan on for this bit because I don't intend to be out here very long. There we go. There we go. And there we go. Lovely. So that's a serial and the audio video connector. Now, where is this? What's this? Bridge rectifier. Yep, that can go on. Comes in a nice little anti-static box that you can reuse, and I bought two of them. Some forward thinking. Okay. So I'll pop that back in there. Pop that in there. It's all good. Okay. Now, a power connector as well. I bought some of those. If I haven't brought it out with me, then I'll wait till next time. Okay. Can't see it. So that'll wait. Right. So here we go. We can see this is marked up. There's a positive and negative. The other two, because it's AC, it don't matter, but there's a notch on it. So just line up the notch and make sure that the positive and negative goes right on the board. In this case, it does not. So I don't like the look of that. I don't like the look of that one little bit. Yep. In this case, the holes are exactly right as well. If I put that in there and it's wrong, then that's not going to go well. So I'm going to keep that to one side for next time. I'll have to have a look at the data sheet to double check that, because that doesn't match the silk screen on the board. So it's not the end of the world. You just got to make sure the pins are right. So it doesn't matter which way the AC is, but the plus and minus coming out does matter, because that will be polarized. But that's, you know, stands to reason. Now let's talk about joystick ports before I wrap this up today. So we're roughly at 4 hours and it's mostly built. There's only a couple of components left, and I'm going to be waiting for some, and this is the reason why. Firstly, CR1, that is a 2.7 Zener diode and 500 milliwatts, and getting hold of the actual 1N1 is like rocking all shit. So I'm going to, oh, it's really expensive getting one. I'm not going to pay bloody £7 for one diode. They can kiss my ass. So I've got a BZX on order, that's coming. The same with the 0.1 50 volt axial over here. Yeah, I've got one of those on order. That's coming. I've got the voltage regulators and other stuff. The modulator I'm going to put on. That's all going to be in part 2 of the video. And we're going to get into ROMs as well. We're going to talk about that. But the main problem is these fuckers. Right, now I've got a shit ton of these. And these are the standard sort of joystick ports you can get. 9-pin D sub, right angle, PCB. And you might notice that the clamps and the pins are in line. On this board, no. It's some fucking no-name white elephant piece of shit fucking connectors, which means I'm likely going to have to take them from a donor board. I've looked everywhere trying to get them. So, yeah. And they're very deep as well. So, yeah. That's going to be in part 2, I should think. So, I'm going to leave this here now. We're roughly at the 4-hour mark, and it's mostly complete. Stitching the cartridge port in, I'll do that when it's fully cured. It's not going anywhere now, it's epoxied down, so that fucker's there to stay. And then it's just a couple of components left. Job's a good one. In part 2, we're going to talk about ROMs, because the ROM structure is not the standard sort of 128, 256 or 512 JEDEC standard. It's a weird kind of standard, and I'm using some open boards that I got from GitHub, Suco Pereira ones. Yeah, so this means you can take a standard ROM or use multiple ROMs, and then we're going to use that for the kernel. The basic I'm going to use this one for, and the character ROM I've actually got a chip from a pull from Retro, so that's no problem at all.